Okay, hello. So I'm going to quickly talk about fusion of heterogeneous data. This is a work, more something that came out from a series of papers together with Florian Straub, which is currently a PhD student, and joint work with Google Brain and Mila. So first, Criteo is a company which is doing retargeting since quite a long time. And we, of course, have a series of problems where machine learning is involved at some point. We need to match catalog. We are very big players for bidding. We handle something like 200 billion requests today, which is one order of magnitude bigger than Google search in terms of numbers of requests. We of course have to do some product recommendation, and we also directly optimize the design of our ads. And everywhere machine learning is involved in order to build our ads. Some is done directly online, some is done offline, and we to serve the best possible ad we can. So I'm going to focus on a sub-problem over this, which is very common for us, which is we want to build a prediction based on several data. For Criteo, it can be catalogs of products which have both pictures and text, description text, and possibly also some feedback from the users. And the current classic way of doing this is to build your favorite embedding of picture using maybe a ResNet. Then you add some, you take your tags, description or whatever, you use another kind of an embedding, and very crudely you could start doing a prediction which is like an average of the two, the vote, or whatever you answerable method you prefer here. Something which is more like end-to-end or closer to what a true deep learner will do is, as one of the previous speakers, and use add a merge layer. The merge layer can be imposed, it can be just cosine if you want, it can be also learned, but here you can hope to answer questions about the pictures. Like here, the color of the cat, the previous way of aggregating the picture couldn't work, couldn't answer the question. Here you have the possibility to do it. But the question is, can we do something better? And meaning that we want the embedding of the image to be dependent on the question you want to answer about your pictures. So a quick recall before that, which is batch norm parameters. Batch norm parameters have been introduced a couple, 3 years ago, where initially tools developed to speed up the training of the networks. What you need to keep in mind is this is designed to work over pictures, and this just add 2 coefficients in front of each of the feature maps of your convolutional networks. And interestingly, there is an earlier work by Vincent Dumoulin, which proved that if you want to do some transfer learnings, to learn style about pictures, usually what you do is for each style, you are going to train one network. And what he did, he showed that it was not necessary to retrain the whole network for each different style. You could use the exact same weight everywhere, but the retuning, fine-tuning, only the batch norm parameters. And what is done in this paper is just have, I think you can go up to, there is no clear limit, but in the paper I think it's 20, but he has as many styles he wants inside the network because he just keeps track of different sets of batch norm parameters, one for each of the styles. So a natural idea here is to reuse the fact that these batch norm parameters are very powerful because they can influence on each of the output of the feature maps, And instead of using the embedding only to predict the last layer of the network, then maybe what you can do is to use your embeddings to modify, in fact, to modulate each of the output of the batch norm parameters of your network. And that's the first architectures we came with. You first learn the embedding, and the embedding modifies the batch norm parameters. Very quickly, the result, of course, this was the best working thing here. But what is interesting is it's almost free. As soon as you want to merge the textual data and visual one, then you can do this. And what we always add at least on all the tasks we tried, we always add something like 2 extra points of performance for free. And interestingly, what happened over the embeddings, this is visual questioning dataset, this one. And you see that this is the pictures, a number TNSNU projections of the picture of the dataset. And for each picture, it was associated with the questions, and some questions were about answering a number, some other yes and no. And you see that, of course, there is no direct relation between the pictures and its questions in the feature space. And as soon as you start to embed the pictures depending conditionally to the questions, you see some groups that start to occur. So the embedding is actually really modified in order to be more easy to build the next answer. Then again, we went a little bit more crazy. We did it over more complicated tasks, and in particular, this architecture, which is maybe a little bit complicated, but is not only using the last layer of the text. Now we have an architecture which is able to exploit any of the any of the activations in order to modify again the output of the batch norm parameters. And in fact, now these batch norm parameters are now separated from, we decided to call that a film layer for features modulation layer. So batch norm is not really useful anymore here. It's just that the idea is really to modify only something like 2% of the weight of a network, which allows some fine-tuning and conditional learning over neural networks. This is the kind of thing that the LSTM is able to do. This is the questions here about the pictures, like in guess what? You want to find the persons described by this text and refer it, and in guess what? You have to answer, to give your own questions. Here the task is not to find these questions. You have these questions and you want to guess who is concerned here. And here it worked exceptionally well. It was published at STCV this year. What is very interesting here is the actual competitor was done by Google Brain, and they had to do a lot of on-crafting tuning in order to be able to answer questions about humans and different kinds of categories. So this thing, their performance here is really a complicated system that you wouldn't maybe put into production, except you are really sure that the data won't change. While here it's really end-to-end and has the same level of performance, basically. Sometimes they are better, sometimes we are better there. And some examples of success, you see, is this a figurine? Yes. It is an animal? Yes. And does it has a hat on, and he discovers these strange pictures here. An example of failure, you see that failure are fairly understandable for humans. This is due usually to the last word, which is very strong. Is it shaped like a ball? And now he is a little bit puzzled because the question is not so clear for the systems. He thinks we are talking about a watch, and then he doesn't show the phone.